However, no problem. A lot of students are doing super well. 100, 100, 100, 110. And this is directly proportional. The student can do the homework, doing well in the test. The student can, I don't care the homework. Failed the test. Okay, pero ya, doesn't matter. Bueno, okay, suppose que you have polynomial function of degree m. That's mean then f of x has m zeros. And what mean n zeros? Means can you count? Is it they are counted. Multiplicity, of course. And complex. Example to understand very well this idea. Suppose que I investigate you have the zeros of the polynomial is 1, 2, 3, 3, 3, and 2 plus 3i. Entonces, the question is, what is the degree of this polynomial? Well, this is confusing, okay? We have 1, 2, 3, 4, 5. So you count 3, 3, 3 like a 1 because it's a multiplicity. And the complex never is coming like only once, by a pair of conjugate. This is 2 minus 3i, escorzo. So the degree is 1, 2, 3, 4, 5, 6, and 7. 7 degree. Okay? This is the polynomial. And remember, polynomial function is a function that the exponent is a whole number. So x to the 6th power plus x to the whatever. So you have fraction, it's no polynomial. And this rule is completely invalid. Or negative exponent, no polynomial. This is no polynomial. Okay? So the rule number 1 is super important because you see the polynomial is degree 7 and we have 7. Include real, positive or negative, non-repeated. Repeated, you count like 3 options. In this case, 3, 3, 3 is a coincidence, it's 3 and 3 times. And the complex is coming by pair of conjugate. Okay? Okay. Suppose another example. More clear to clarify this idea. Okay, it's the first property we studied. I promise we have more. Okay, suppose que en el test is given this. It's given this. Okay. You, find the equation. Find the equation. Of a polynomial. And this polynomial has several zeros, like that. The zeros of this polynomial are 1, 1. Wow, entonces 1 is repeated. And negative 4 plus I. Entonces, this is the idea, find the equation. Okay, entonces si es repeated, es obvio que my function incluye x minus 1. Remember, this is a 0 and the factor have opposite sign, no? Time x minus 1 to time, no? Much better, in my opinion, is square. Like that, right? And we have this complex is given, but I know that we have another complex, it's the conjugate of this case, negative 4 minus I. Remember, the conjugate is the same sign, in the real part, but opposite sign in the imaginary part. So you have x minus -4 plus I multiplication x minus -4 minus I. What is this? Sorry, profe, my laptop was dead. Okay, guys, this is situation happen. I understand. You can see in the YouTube the video. Entonces, maybe the question que fly in the air. What is this format? Remember, the format for the factor is x minus something, no? It's the format. And the 0 associated with this factor is x equal a. Entonces, si es 1, that is the reason I put -1. And you put minus here, because it's the same format, look, minus. And I put in the parentheses the two complex. Do you understand this or no? Clear, right? Clear or no?
Yes.
No?
Professor, since you said like the conjugate has like opposite signs for the imaginary, so
Exactly, only that.
Okay.
Okay, what is the conjugate 2 plus 3i? Is 2 minus 3i. So the real part stays the same, and the imaginary no change the sign. Okay? We studied this in the chapter 1. Yes or no?
Yes.
No, it's okay. I understand. It's important in the learning process. Repetition, until you get the idea. Okay, now this is leave it like that. Well, no. This is ugly. Entonces, I propose you do the multiplication of this. I want to separate this. The real part and the imaginary part. I prefer doing first the imaginary part. So you FOIL in the story, FOIL. How? X times x squared. X times something. Entonces, es minus, ¿no? Es minus porque this is minus. Es minus x times -4 minus I. And this time, this is similar, es minus x again, pero es -4 plus I. And finally, multiplication, this and this, que es plus, because negative is positive, the multiplication, -4 plus I, and -4 minus I. Everyone follow me so far?
Yes.
Okay, the multiplication, this guy, I remember very well what we were doing before. I remember that the multiplication to complex number, que they are conjugate, the answer is real. And the shortcut to do super fast is multiplication. Real, imaginary. Real is -4 times -4 is 16, no? Plus, always plus, and the coefficient here is 1, and the coefficient here is 1, plus 1 is equal to 17. Do you remember this? Or you want que I do by FOIL? It's shortcut. Do you remember this or no? No?
Yes.
Yay, she remember. Okay, this is the advance for the student in pre-calculus in college algebra. The student in kindergarten doing first, hour, in, and last. Okay, now, and the other part, when it's x squared plus 4x, I distribute it, look. Plus ix, minus no plus, again, 4x. Minus ix plus 17. Okay, so we combine later. It's easy. Well, that part is cancelled out. It's magically. The imaginary part disappears. That is a reason that the complex is coming by pair of conjugates. So 4 plus 4 is 8 plus 17. Okay, I did the multiplication of the part que look like hard. Pero no, it's not hard. And this is super easy. This is straightforward. This is x squared minus 2x plus 1. Yes or no? Now finally, multiplication of this and this together. So basically, x squared minus 2x plus 1 times x squared plus ax plus 17. Sorry, I have wrong sky call somehow. Okay. You know, every lecture I send new link. Okay, because si suppose que I drop some student, I eliminate my list, and we can not enter any more in my lecture, no? So any lecture I send new link. Someone made the call through the. Okay, Maricelis, open the link, open the last email I sent to you. Professor, my name is not shown in the list element. Wow. You are complicated, guys. Focus in mathematics. This is the most important moment. The attendance is, you know, is important, but not too important. Okay, entonces you are now foil. In this case, we have 9 combinations, no? 3 and 3 together is 9. Entonces x to the 4th power plus 8 x to the 3rd power, because it's 2 plus 1, and 17 x to the 2nd power. I did the first, multiplied by 1, 2, 3. The second is minus 16x squared minus 34x. And the last one is plus x squared plus ax plus 17, you know, because it's 1, so it stays the same. Finally, we combine later x to the 4th power. Who's lighter? This is light, and lighter, because have the same exponent. And what? Espérate. I'm making mistakes for sure. X to the 4th power. Okay, this is cubic. This is a square. I forgot something. Yo. Okay. Repetition again. I don't see the mistake, but I have a mistake. This is a stupid mistake because this is mechanical. But okay, it's a mistake. Okay, let's do it quick. Slow down. X to the 4th power plus 8 x to the 3rd power plus 17 x to the 2nd power. Okay. Now, the multiplication of this guy times this guy is minus 2 x to the cubic power. This is the thing I forgot. I don't know why. This is negative 16 x to the 2nd power, and this is negative 34 x. Super. Okay, the last one is super easy. The last one is x squared plus ax plus 17. So this is a crucial moment in which you apply combined like term. Who is like? This is like with this. Entonces, a minus 2 is 6. Who more is like? Bueno, like is 17x squared, 16, and 1. It's easy because 17 minus 16 is 1, and 1 plus 1 is 2. This is 2x squared. And one more, 34, and a is 16, no? Minus 16, minus 16, no, minus 26, minus 26x plus 17. Bam! End the story. It's the equation for the polynomial que satisfy that condition, ¿no? Que es que the 0 are, let me close in the box because it's important. Too hard to get that. Entonces es of important. Okay, que satisfy the condition, ¿no? The condition, remember, is 1, 1, 2 times, and this complex. Well, one complex is given, another no. Another complex I infer by the property que say que the 0 of the polynomial is coming by pair of conjugate. Always. When the coefficient is real. Es obvio que normally, well, 99% of the scenario, the coefficients are real numbers, 1, 6, 2, 26, negative, 17. Entonces es obvio que the coefficient is coming by pair of conjugate. Do you understand very well? Yes or no?
Yes.
Yes, I understand.
Super. Okay, the second important thing, we have 3, is I want to erase the board. I can? May I?
Yes.
Yes.
Go ahead. The second important thing is one fantastic theorem, que the name of this theorem is rational zero theorem. Let me try to explain. The word rational indicates us always fractions or decimals. So the rational number is, 1/2, 3/4, or decimal, 0.5. This is 0.75. Irrational is a number that we cannot express it like that. No. It's pi, pi like a 2. It's irrational. Never we can express it like a fraction. So now this theorem discover the potential possibility to have fraction whole number, because whole number is a particular example. The rational, for example, si the 0 is 2, you can interpret it like a 2 over 1. It's also rational. Then, entonces, what is the reason, Professor, que you say potential? This is important, because the theorem do not guarantee 100% the existentness of this zero. But at least give me a clue. Of course, I bring one fantastic example, to illustrate perfectly this idea. So what is the idea? The idea is you take, in the polynomial, for example, it's much better to see using example. You have this example, is 2x to the 4th power. Of course, the example I select is a happy end. It's like everything is nice. No always happen, but frequently happen. Suppose we have this polynomial. Okay. By the way, what is the degree of this polynomial, guys? Help me. Help me to understand this.
4.
What is the degree? 4. 5? No, 4, coño. It's 4. What is the higher?
Why not 5?
What is the higher? What is the higher? So no coefficient, no. You analyze the exponent. What is the higher exponent? 4, no?
Okay.
Okay, got it. How many zeros? When I finish the problem, we expect to get. How many zeros? How many zeros? I explain right now, no? In the first part of this lecture, no? How many zeros? How many zeros? What's going on? 4 0. So the same, in the polynomial always, the degree is equal the amount of 0. We expect 4 zeros. Okay? I want to discover how. Well, using this theorem say que one clue is determine one thing is the formula is plus or minus P divided by Q. And who is P and who is Q? P is the coefficient and the 0 degree, que es 6, without signs. The sign is not important. And Q is the leading coefficient que is the coefficient and the monomial que have higher degree, ¿no? Que 4. Entonces 2. Entonces there's plus or minus 6 divided by 2. Oh, of course 3, pero no. We analyze in that way. You analyze every possibility of the factor of 6. Que is, plus or minus 1, plus or minus 2, plus or minus 3 is a factor of 6 and plus or minus 6. The easy way to understand this, you multiply like that. 1 times 6 is 6, 2 times 3 is 6. Okay, it's the possibility of the 6. Likewise, we are doing possibility of 2, que es easier, plus or minus 1 and plus or minus 2. Everyone follow me? So you take P and Q. You take P and Q. You consider always double sign, plus or minus. And you break it down 6 and the several possibility of factor can include 6 and 2 exactly the same. Now this is the most important moment, the list of the potential 0 is, look, you for example take the first and the first and the first and the second, pero sequentially, no? Okay, the first is plus or minus 1, sorry, plus or minus 1. Okay, welcome from this one is 1 divided by 1. And likewise, 2 divided by 1, 3 divided by 1, 6 divided by 1. Entonces, when this one is the same. Plus or minus 2, plus or minus 3, and plus or minus 6. Now, I finish every combination using this one. Now, I'm using the combination of 2 when the top number, no? Es obvio que is plus or minus 1/2. Wow, we come from 1/2. It's 1 divided by 2, no? And now the second is 2 divided by 2, que es 1. Entonces, I have here, I don't need to repeat it here. The second is 3/2, plus or minus 3/2. And the last one is 6 divided by 2, que es 3, que I have here. Entonces, now, I listing my potential 0 of this polynomial. Do you understand this idea?
I have a question.
Go ahead.
So why didn't you rewrite the 3 after 3 over 2?
Is, look, in the last combination, is this and this. 3 divided by 2, 3/2. Do you see?
Yeah.
Sure?
But I meant because 6 over 2 equals 3. Why would I rewrite the 3
6 over 2 is 3, you are right. And 3, not necessary to write here because I have here. Make sense?
Okay. Yes.
As you repeat, it's a little bit stupid. No, not necessary to repeat because, in the set, no repetition is allowed. And the ordering is not important. Okay, now this is a clue. Look at the complicated thing. This is a clue to start synthetic division, step by step. Let's do it because this is our job. This is auxiliary, complementary idea. Okay. Remember, we discovered 4 zeros. I don't know si complex, real repetition, or no. So you are doing synthetic division, exactly the same we're doing. S2, F5, is -2, -11, and 6, and -6. Don't forget the signs. And I select one guy, I select -1. Bueno, I select -1 porque I did before. Yeah, I know que -1 works. Suppose you select +1. When you perform the long division, there's no 0 remainder, therefore, it's no factor. Entonces, no, in order to save time, another possibility, remember, we're using decimals. No? You are doing double checking in decimals. In decimals, you see super clear what work or doesn't work. This idea is without decimals. So in the jungle, no internet, no computer, okay, and 17th century, when the mathematicians have no technology. But okay, here, yes. Entonces, I doing standard division using -1. Bring down 2. Multiplication is -2. Addition is +3. 3 times 1 is -3. Is -5. -5 times -1 is +5. And this is -6. -6 times -1 is +6. 0. But I discover que the factor x plus 1 belong to the polynomial. This is factors. And this is zeros. The 0 is 1, que es exactly the number que we use. Es -1, sorry. It's exactly the number that we use in the standard division, -1. Okay, let's continue. Remember, it's guessing, but a little bit smart guessing because you have a list. Another guy, I repeat -1 again. Ooh, -1. Why, professor? Because when you see in decimal, you see a -1, the graph touch the axis and the multiplicity is 2. Okay, but I continue guessing. Bring down 2. 2 times -1 is -2. This is 1. Multiplication is -1. This is -6. Multiplication is +6. 0. Okay, so the factor x minus 1 is repeated, x plus 1, sorry. And the 0 is 6. So that means que en -1 we have 1 0 multiplicity 2, ¿no? Bueno, so far, I don't know si continúa -1, pero no -1 anymore. Now we continue standard division using -2. Que -2 belong to this list also. Look. Okay, entonces es, let's try, bring down 2. 2 times -2 is -4. This is -3. And -3 times -2 is +6. Again, 0. Si es 0 remainder, entonces the factor x plus 2, ¿no? Belong to the polynomial que de 0 es -2. Bueno, the last factor is this, que es x to the 0 and x to the 1. So actually it's 2x minus 3. Okay, and 2x, look, the factor is 2x minus 3. And the 0 is when you take 2x minus 3 equals 0, and you solve for x. 2x equals 3 divided by 2. Wow, it's 3 over 2. Exactly the list predict. Positive 3 half. Then we have several candidates. But you don't know exactly si work, doesn't work. Entonces, the most worst scenario is that you try to do your best and you don't find anything. Because the theorem do not guarantee 100% this. But it's at least one thing. Okay? However, we're using technology. We put a graph in decimals and you can see a little bit more clear the idea. Okay, let me explain another. Everyone follow me? Do you understand very well or no? I promise in the review package, we go over doing a lot of problems of this. Question.
Professor, couldn't you have also used -1 for the third synthetic portion? Or like it doesn't matter.
Yeah. Okay. Suppose que you use, okay. Your question is why you use a -1 again, repetition, no?
No, because I saw you use -2. So did because I know you said you could use any number, like you could try with any number, but
you using any number inside this list. The list helped me a little bit to understand the number. I using this number. However, if I using the wrong number, you never get 0 here. And this not 0 is because this factor that you try to prove don't belong to the polynomial. Clear?
Yes.
I know que es too long process. Entonces I did before this problem. No, I try, it doesn't work. Try, it doesn't work. Try, it doesn't work. No, I try the number que I did before in my piece of paper. It worked. Okay. In the real life, you are smart. You open Desmond, you put equation, and you have one picture que illustrate very well at least the real zero, positive or negative, and you try to prove in the scientific division. Okay, one more clue. One more clue I want to explain. May I erase the board? Yes or no?
Yes.
Okay. Okay, another rule que somehow give me information about the zeros of the polynomial is called Descartes rule. Descartes. Rule. This is easy, but it's a little bit complicated to explain. Let me try to do my best. When you get the idea, you understand. Super easy. But to explain, you let me explain. Don't interrupt me, please. Entonces, in the several examples, you got the idea little by little. Then you have one polynomial. You have one polynomial. X to the fifth power minus 6 x to the fourth power plus 12 x to the cubic power minus 12 again x to the second power plus 11 x minus 6. Let's give it this polynomial. So you apply the Descartes rule for this polynomial. Descartes say, the rule of Descartes say, the amount of positive zero, real zero, positive, real zeros. I want to call like that, positive real zero. Is, somehow equal the amount of change of sign. O sea, P. Who is P? Espérate. P. P. Who represents P? P is the amount of change of signs in the polynomial. How do you understand this? Well. This guy is positive. Wait. This guy is positive. And this guy is negative. Therefore, we have one chain of sign. I indicate like that. Positive to negative. Again, another chain of sign. Oh, another chain of sign. Oh, another chain of sign. Oh, another chain of sign. In total, how many chain of sign we have? Well, we have 1, 2, 3, 4, 5 chain of sign. Okay, there's a capital P, F5. Okay, entonces Descartes say the amount of real positive zero is equal to this number, pero not always is equal to this number. You decreasing even number. So F5 maybe, or is 3. Where I come from this 3? One is 5 minus 2. Or 3 minus 2 is 1. And 1 minus 2 is negative number. Have no sense. So the conclusion for Descartes say, for sure, I guarantee 100%, that this polynomial have 5 real zero positive, or 3 real zero positive, or 1 real zero positive. And the conclusion of this example, you see exactly what is the true, because only one is true. So far, everyone follow me? I need to repeat something?
Yes.
Okay. Okay, entonces, what about the negative? Oh, what is the discrimination with the negative? No, no. The negative is similar, but the negative real zero, the negative real zero, I want to represent like that. You determine using another parameter que es called no p, es m. Okay, entonces, what is the pain? Bueno, what is the m? When you make a reflection of this polynomial, so you replace x for negative x. This is easy because it's similar to the original, except that the exponent even 2, 4 stay the same, because you know that negative x to the even exponent is x to the even exponent. So magically, the negative 1 disappears, right? However, when it's negative x to the odd number, well, the negatives go outside. This idea is clear or not? See, this idea is clear. So this is negative x to the 5th power in the reflection, minus 6, x to the 4th power stay the same, minus 12, x to the cubic power change. This stay the same, and this change, and this stays the same. So now, what is the amount of negative? So negative capital N means the amount of change of sign in the polynomial after the reflection. Give me information about negative real zero. Wow, I saw can never change. Negative, 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 negative. So I determine that the amount of negative real zero is 0. We have no. Okay? And that's it, no? No, because we have several possibilities. So I create a chart like that, easy, in which you put positive, negative, complex, and total. Okay, so we have different possibilities. The positive I investigate using Descartes rule, que is 5, 3, or 1. The negative I investigate using Descartes rule, que is none, 0. The complex, I have no idea. And the total, yes, I have idea. What is the total? How many in total 0 have our polynomial, the original polynomial? What is the degree of this polynomial? What is the degree?
5.
5. So how many 0 we expect when you fit the problem in the polynomial?
5.
5.
This row is only 5, 5, 5 for any combination. 5, 5, 5. Okay, now the complex, you know, the complex always is coming by pair of conjugate. Have no sense to say complex is 3. No, even number. Or it's 2, or 4, or 6 complex. Because it's coming by pair. Okay, the husband and wife. Get married, the complex. Entonces, si I know que the total 5 is because in this combination, in this column 1, column 2, column 3, the 3 possibilities we have is 0. Because 5 plus 0 is 0. And it's a 2. 3 plus 2 is 5. So maybe we have 2 complex. And 4. Because 4 plus 1 is 5. Okay? Okay, now I want to prove now. This is a clue. I want to prove that the combination works is this. I want to prove. And there is some question in Alex in the review package of the reading test. Okay, you finish here. You are doing the chart. You discover the possibility. Not too much, because the other part is, you know, is long. Entonces, now, what is the idea? What is the idea? What is the idea? One of the idea, suppose we continue. Well, we apply the zero factor rational zero theorem, que es, remember the idea of the, suppose I need to continue this problem. It's plus or minus P divided by Q, no? Okay, we see before. P es 6. Entonces plus or minus 6. And Q is 1. Entonces sí. There's 1 here. We have only one combination. Actually, the rational 0 of this is, let me see, is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. This is the candidate to be a rational real 0. But we discover using the Descartes rule that maybe we have 3 positive, 2 complex. Oh no, I don't know, 5, and never negative. So the negative is totally discarded. But okay. How you prove mathematically? Well, synthetic division. It's the only way we have. Synthetic division. Make a zoom to see more clear synthetic division. Of course, as always, I did this problem, no? Entonces I go directly to the value that I know that works. The other value that doesn't work, I don't want to waste time, no? This is 1, negative 6, 12, negative 12, 11, and negative 6. Here I try using 1. Positive 1. Okay. Bring down. Multiplication. Subtraction. Multiplication again. Subtraction. Multiplication again. Subtraction. Multiplication again. Subtraction. Multiplication again. Subtraction. Discover that x minus 1, because remember the factor is opposite sign. This is a factor. You don't need to write everything. I am teaching to say I explain everything, any possibility. Depending on the question. If the question says factorization of the polynomial, you use the factor. If the question say find the zeros, entonces your answer is only that. X equals 1, that by the way is the same number of these. Got it? Let me try 2. Okay, 2 is positive. Remember we have no 0, no negative. The negative is no good. Bring down 1. Multiplication 2 is negative 3. Multiplication is negative 6. Subtraction is 1. 1 times 2 is 2. It's a negative 3. Multiplication is negative 6. Again, 0 remainder. Therefore, I discover that the factor x minus 2 belongs to the polynomial and the 0 is 2. Okay, very well. Now, I try 3. Bring down 1. Multiplication is 3. Combine here. Is 0. Because 3 minus 3 is 0. 0 times 3 is 0. And 1 multiplication is 3. Again, 0 remainder. Nice. The factor x minus 3 belongs to the polynomial. And the 0 is 3. And this is magically the famous 3 positive 0 que have that polynomial. 1, 2, 3. I create this example funny, no? 1, 2, 3. 1, 2, 3. And we have no. And what about the complex? Two complex. The Descartes say okay, you have two complex. One, okay. To discover the complex, well, you take the quotient part, the last part here, and this is x to the 0, and this is x to the 1, and this is x to the second. So actually, the translation of this polynomial is x squared plus 1. Okay, by the way, this is irreducible quadratic, no? This is reducible quadratic. So the factor is x squared plus 1 irreducible quadratic. And by the way, so you put equal to 0 here and you try to solve in this quadratic equation, es obvio que s squared is equal to -1, apply square root both sides, x is equal plus or minus I. Wow, that is the reason que es irreducible quadratic, because this represents two zeros, imaginary or complex. So actually this is x is equal plus or minus I, the zero. Entonces en total, remember at the beginning, this polynomial degree 5, no? We have in total 1, 2, 3, 4, and 5 factors. Well, actually it's 4 factors because and 5 zeros. 1, 2, 3, 4, and 5. Exactly Descartes rule predict in this second column. 3 positive 0, never negative, and 2 complex, in total 5. Suppose, entonces, okay. Suppose que the answer que they want is, okay, factorization the polynomial, professor. Okay, let's do it. You copy x minus 1 times x minus 2 times x minus 3 is a real part, positive, and x squared plus 1. Okay, this is in the real field. Suppose que the question say, no, in the real field, no. In the complex field, entonces x minus 1 times x minus 2 times x minus 3, and you break it down, this guy, in two linear factors, x, I, plus or minus. This is the same factorization, but this is weird. Never we are doing this in intermediate algebra or Euclid algebra. We are doing now in pre-calculus or in integrate algebra. This is a complex field. It's in the case que ask you in the complex field, or another word que is synonym or similar is using linear factor. Linear factor indicate degree 1. And this is not degree 1, this is degree 2. Okay, degree 2 is irreducible quadratic expression. Okay, this is the idea in factorization. Entonces, suppose another question que say, no, I don't want factorization. I want listing the zeros. Okay, entonces the zeros is, suppose, real zero, only real, strictly real. No, the complex ese alien, I don't want alien. Es 1, 2, 3, end of story. Suppose no, total zeros include complex total. Es obvio que we have 5. Es 1, 2, 3, and I, or plus or minus I, you can write like that. Or 1, 2, 3, I positive y I negative. In total, 1, 2, 3, 4, 5. Super clear or super confusing? Okay, entonces we have a lot of tools to analyze polynomial. Let me summarize. Polynomial, you analyze degree. The same amount of zero is equal to the degree, include repetition, so multiplicity 2, and include complex. And the complex, of course, is coming always by pair of conjugate. Let me try to find one nice problem. Okay, this is nice. Yeah, this is a nice, no big deal. We have the fantastic plus or minus P over Q, que es the rational theorem, que give me somehow information. So sometimes work, sometimes doesn't work, but in this case work. It's positive 1, positive 2, and positive 3. However, I discovered using the Descartes rule that the negative no good. Entonces, maybe I try 6, but 6, when I do it by scientific division, I suppose it doesn't work. No. Okay. Do you understand or no? Of course, you need practice. I bring today some more problem, but you need to try by yourself. And the way to do by yourself is doing the homework in Alex. Okay? Okay. There's no problem. I can erase the board. Sure. You understand, or you are lost? Totally lost, no? Totally lost in this subject. Hey, guys? Come on. Comment. Professor, I need to drop this class because it's too hard, huh? Oh, no? Come on,
I think it just takes practice.
Absolutely. Mathematical practice. Okay, you understand the concept and you apply the concept. And behind the concept, we have a lot of, equation, arithmetic operation. The only possibility to face good is doing the problem, doing a lot of problems. Suppose another example. Suppose g of x, polynomial again, x to the 4th power plus x to the 3rd power minus x minus 1. Okay, good, very good. What is the degree of this polynomial? What is the degree?
4.
Therefore, when you finish that problem, we expect 4 zeros. Number of zeros is 4. Include a repetition, include a complex, or imaginary. Because imaginary is a particular example of conjugate. Entonces I have no idea how you face that. Well, no, let me start. Maybe we are doing using the plus and minus PQ. Okay, who is P? P is 1. P is this guy. Remember, I don't care this sign. Why I don't care this sign? Because I put plus and minus. I include every possibility. A1 es plus and minus. Let me put plus and minus, but no individuals, in the front. 1 divided by Q. Q is this coefficient. Okay, it's also 1, no? Because it's missing. It's invisible. So we have only 1. It's plus and minus 1. It's plus and minus 1. And the least of the potential 0 is 1 and negative 1, or negative 1 and 1. The order is not important. Well, okay, I try. Now let's analyze Descartes. Of course, in my opinion, the first thing you should do is put in decimals. Okay? But well, okay, let's try by hand. Suppose I am the jungle, only banana and monkey. No computer, no internet, no nothing, right? See, you are in the jungle, maybe you don't need polynomial. You need banana and food. But okay. Okay, entonces now Descartes. Descartes, I copy g of x is equal x to the 4th power. I copy the original again. Okay, you determine capital P. Who is capital P in this? Capital B, remember, is the number of check cosines of the polynomial. This is positive, this is positive. Don't check cosine. This is check cosine because it's negative, and this stays the same. P is 1. P is 1. And 1 is 1. Definitely, we have only one potential, 0 real. That means, remember, this sign indicate real, positive, 0. We expect only 1. Okay, nice. I like that. I make a reflection now. Entonces, this stays the same because the exponent is even. This no, is change. This change also. And this stays the same. And capital N is the amount of chain of sign. Okay, is a negative, positive chain. This is negative positive change. This is positive negative change. Therefore, M es 3. Ajá, entonces 1 es 3, es 3, and 3 minus 2 es 1. So, conclusion, the real negative is 3 or 1. We have two possibilities. According to the Descartes rule, no? This is the real negative zeros. In plural because we have two possibilities. And immediately, to finish the Descartes rule, I create my chart. Okay, my chart is always the same format: positive, negative, complex, total. Okay. The positive is 1. Always. The negative, no. The negative is 3 or 1. So we have two columns, no? And the total, I know, gets 4, no? Because the degree of the polynomial is 4, no? And this combination in the column 1 is 1 plus 3 is 4, also no complex. Under the consideration que no complex. In this case, it's 1 because we have only one possibility. So actually, we have only one possibility of the real positive 0. And 1 plus 1 is 2, so we need two complex. I want to prove que the possibility in the column 2 is the possibility que work. But this is a clue. So, and you try scientific division using the guy que I listing in the other theorem, que es 1 and negative 1, no? Okay, so I split the paper because in the right hand side, I want to do scientific division. Okay. Let me try to do my best in the scientific division. Okay. We copy this symbol of the scientific division. I copy the coefficient to don't loss. I put x to the 4th power. This is a guy can help me to put in your correct place. Okay, the coefficients. I come back to the polynomial. Look, in the polynomial, the original polynomial, the coefficient here is 1. Look here. The coefficient here is also 1. Super. And the coefficient here, do not exist. It's 0. Be careful. It's a typical mistake. And the rest is negative 1, negative 1. And remember, I use now this guy. In either order. The order is not important. In my paper, I use 1 first. I don't know why. Sure. 1. Bring down the first number, multiplication, addition, in this case 2. Multiplication is 2. Addition is 2. Multiplication is 2. Subtraction is 1. Multiplication is 1. 0 remainder. When you get 0 remainder, I'm super happy because I discover that the factor x minus 1 belongs to the polynomial. And the 0 is 1. The other possibility is negative 1. Okay, let me try negative 1. Maybe they are multiplicity, I don't know. So you try 1 again and doesn't work because remainder is not 0, entonces that means que no more 1, only 1. Entonces bring down 1, this is negative 1, this is 1, this is negative 1, 1 is negative 1. The 0 remainder, perfect. Entonces the factor x plus 1 belongs to the polynomial. And the 0 is negative 1. According to Descartes rule, look, we have one positive, okay, I suppose que es this, and one negative, okay, I suppose que es this. So we have two complex. How you find the complex? Well, the complex is this part. Okay, by the way, this is quadratic equation. So some people some students, including me, prefer don't continue doing scientific division because I know very well how you're solving any quadratic equation. So this quadratic equation is, for me, is nothing. This is x squared plus x plus 1 equals 0. And the solution for this quadratic equation is pretty easy. Let's do it quickly. A is 1. B is 1 and C is 1. I want to copy again quadratic formula minus b plus or minus square root b squared minus 4ac divided by 2a. Es 1. Wow, everything is 1. Entonces es negative 1 plus or minus square root 1 squared minus 4 times 1 times 1 divided by 2 times 1. The expression inside the radical is 1 minus 4 and negative 3. Wow, it's complex, you know. And the square root of this is I radical 3. We cannot simplification more because radical 3 is prime number. Okay, so now we have negative 1 plus or minus I radical 3 divided by 2. Remember, you can write like that, negative 1 plus or minus I radical 3 divided by 2, but no good, because C is complex, you separate the real part and the imaginary part. Suppose the question say, well, listing the zero, okay, and the real field, zeros, real field. Well, it's only 1 and negative 1 in the story. It's this guy. 0 and the complex field. Complex include real complex. Field is, of course, include real and complex. And the complex is this, and negative 1/2 plus I radical 3 over 2, comma, negative 1/2 minus I radical 3 over 2. And one more time, you confirm it, you can see that the complex is coming by pair of conjugate. You see the real part is the same, negative 1/2, however, the imaginary part, no? Entonces, the factorization, suppose the answer que day one is no zero anymore, no. Factorization, the factorization and the real field is, well, es x minus 1, que es the factor que yo discover en scientific division, x plus 1, sorry, and stay in the real field one irreducible quadratic expression. Like that. Just this. Okay? It's a factorization. Nice. The factorization in the complex field similar is x minus 1, x plus 1, and you break it down this using this case. Let me use in bracket. X minus negative 1/2 plus I radical 3 over 2. Look like horrible, but it's okay. Multiplication by x minus negative 1/2 minus I radical 3 over 2. Done. Any question? One more example, or you are boring to see that?
One more example.
Okay, no
I
problem.
have a question.
Go ahead.
So with the two, like the x minus negative 1/2 plus imaginary 3 over 2. So those two would count as like the real negative zeros, or like, because I thought we were supposed to have 3.
3 what? Wait. What
real negative zeros. Or no?
No. Okay. Real is this. This is real, and this is real. And this is not real, imaginary or complex, and this is complex.
Yeah, but isn't like, because we only have -1, so like, are we supposed to have 3 real negative zeros?
No. When you suppose that, look at Descartes. Descartes was clear. Descartes negative real is 1. Negative real is 1.
Oh, okay, sorry. I was looking at the I was looking at the before we put it in the chart.
Porque
Yeah.
you suppose this option.
Yeah, I didn't look at the
Okay,
second.
sorry. Descartes is a little bit weak. And Descartes give me 2 possibilities. Or it's this or it's that. But only one. So how do you know? Well, I have no idea. I start with the scientific division, bam, 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 y I discover que es one real positive, que es 1, and one real negative, que es -1. And the other guy, que we need to complete the polynomial because the degree of 4 is complex. So actually, the column que es valid in this example is the column 2. That is the reason I highlight this column. Super good or super bad?
Yes, thank you, sorry.
Another question. Okay, one more polynomial. One more polynomial, and you help me. And you help me. Suppose f of x equal x to the 5th power plus x to the 4th power minus 6 to the 3rd power. This is 6 plus 12 x squared minus 40. Don't be scared when the number is big. We use a calculator, of course, plus 32. Okay, what is the degree of this polynomial? What is the degree, please?
5.
5. How many zeros we expect when you finish?
5.
Exactly. They are perfect coincidence with the amount of zeros. Good. Okay, entonces I am totally lost. Let me try to do my best using, the order is not important, but I don't know why. I prefer using plus or minus p divided by q, no? Who is p? P is 32. P is 32. And q is 1. When the q is 1, entonces only the combination for the p. Que es 32, the factor of 32 is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, wow, long, and plus or minus 32. How do you know how you organize this? See, at 32, the answer, you multiply this guy times this guy, 32, this guy, 32, this guy, 32. Doesn't matter the order, no? Pero, so you know the algorithm to organize the list. So I try to prove this. I promise inside this set we have at least 1, 2, 3, 0. Okay, pero no. Let's do in Descartes. Descartes help me a little bit to understand the situation. Minus 6 x cubed plus 12 x squared. I copy again. Minus 40 x plus 32. Entonces en Descartes you need to find p. P is the number of chain of sign. I like this way. I don't know if you like. You see positive, don't say change. Positive, negative, change. Negative, positive, change. Positive, negative, change. Negative, positive, change. How many? 1, 2, 3, 4. F4. P4. See, P4, the amount of positive 0 is 4 or 2 or 0. Entonces, how do you find that? You count how many chain of sign we have at the polynomial, 4, and you decreasing by 2. 4 minus 2 2. 2 minus 2 is 0. 0 minus 2 is negative. Negative has no sense. Only 4, 2, because we are find or try to find the number of positive 0 is possible have in this. So in total we have 5. Maybe you have 4 positive or 2 positive or no positive. Now the negative is similar. You are making a reflection of the polynomial. Remember, it's easy the reflection because you change the sign only in the of the exponent, no? And the even exponent stays the same. This change. This stay. And this change. And this stay. Entonces I need to find the number of negative is, you know, aquí we change one sign. No. Wow. N is 1. O sea, in the worst scenario, we have only one negative real. Okay. Let's try. No, the chart. Let's do in the chart. The chart of the combination. This is not mandatory, but help me, at least for me, to understand this. Complex and total. How many columns I suppose we have in this chart? I suppose we have 3 columns because in the positive we have 3 combinations, no? Okay, 4, 2, and 0. In negative, no, we have 1. So I repeat 1. And the total I know get 5, no? 5 because the degree of the polynomial is 5, no? So in this scenario, column 1, we have 4 positive real, 1 negative real, and no complex. Okay, and the second scenario, column 2, we have 2 real positive, 1 real negative, and 2. Because 2 plus 2 is 4 plus 1 is 5. In the last scenario, we have no positive real. This is no problem. In my opinion, no probably that this situation happen. But okay. Entonces es 4 here. I want to prove now that this combination is a good combination. Okay, I feel que es probably. Okay? How? You prove that. Scientific division. Doing. Okay. Be careful with the scientific division. Because remember when the one guy is missing, you put 0. But in this case, no. In this case, no missing. You organize like that. X to the 0, X to the 1, X to the second, X to the third, X to the 4, and X to the 5. Entonces no es necesario too long. Erase that part. Okay. Something like that. Entonces you copy the coefficients. The coefficients are 1, 1, negative 6, 12, negative 40, and 32 positive. And you try. I try. Remember, I did before. Yeah, I know what the factor get worse. I don't want to waste the time with the factor that doesn't work. I try negative 4. Negative 4 belongs to the list, no? Let me see. You check it out. Negative 4, negative 4. Oh, yeah, negative 4 is here. Look at that. Negative 4 belong to the list. Bring down 1. Multiplication is negative 4. Subtraction is negative 3. Multiplication is 12 positive. This is 6 positive. This is 24 negative. This is negative 12. Multiplication is 48. Subtraction is 8 positive. And multiplication is negative 32. Wow, I like that. The factor x plus 4 belongs to the polynomial factor. You know que it's easy. I know que it's too long. This is not the point. Remember, we are taking advanced mathematics class, no, this is not kindergarten. But es obvio que es too long. Entonces, spend time. Zeros is x equal -4, que es exactly that value. Let's continue. And you see que the polynomial de degree 5, however, when you are doing one-sided division, the new polynomial que you get in the answer at the bottom here, the degree of 4, so reducing, because you factor out x plus 4 and stay in the hypothetically parenthesis in the right, another polynomial with the degree is 4. And what is this polynomial? This polynomial, x to the 4th power minus 3x to the 3rd power plus 6x to the 2nd power minus 12x plus 8 alone. Now suppose 1. Suppose 1. Bring down 1. Okay. Multiplication is 1. Subtraction is -2. Multiplication is -2. This is 4. Multiplication is 4. Subtraction is -8. Multiplication is -8. 0 remainder. Now the factor x minus 1. Remember opposite side to this. And the 0 is x equal 1 positive. It's the same value. And now the next polynomial is degree 0, 1, 2, 3, third degree. Now we continue simple division, divided by 2, que belong to the famous list. So we are doing this 4, remember? We are doing positive 1. Okay, this guy worked perfectly nice. I love you, this guy. And positive 2 is this guy. Okay. Bring down 1. Multiplication is 2. Subtraction is 0. Multiplication is 0. 4. And 4 times 2 is 8 positive. 0 remainder. Now the factor, I discovered that the factor x minus 2 belongs to the polynomial that the 0 is positive. Okay. I feel no, because remember we are working with the polynomial degree 5 and we discovered 3 factor. 2 positive, look at that. Bam, 2 positive. What is this? Combination, let me change the color. Red is good. Look. And 1 negative. What is this? So we expect, and the rest gets the upper part. Okay, by the way, this is quadratic. We expect complex, 2 complex. This is x squared plus 0x, mixing the upper part plus 4. Okay, this is the last factor, que es irreducible quadratic. If you want to determine the 0 associated with this factor, well, you put equal to 0, and you solve this equation. Square root both sides, plus and minus 12. Is x equal plus or minus 12. Okay. Entonces, to finish that, as always, we're listing the potential answer for this problem. Factorization in both field and 0 in both field. Factorization in the real field is x plus 4, x minus 1, x minus 2, and x squared plus 4. Factorization in the complex field is x plus 4, x minus 1, x minus 2, and you separate this into linear factor xx, and this is 2i plus or minus. Everyone understand very well this or no? Sure?
Yes.
Okay. Real 0 and real field. Well, we have only -4, 1, and 2. Doesn't matter the order. 0 and the complex field. Same thing, and include 2i and negative 2i. Okay, if you want, there's no any problem to write using the symbolic way and double sign. It's the same. Do you feel good now? Do you feel good now? Do you feel good now? Yeah?
Yes.
The rest is up to you. The rest is up to you, right? I promise in the review packet we continue doing over this idea. Okay? But I suppose it's enough, no? So today we have time to start new section, important and complicated sections. Okay, important and complicated section. Okay, it's a section about, let me type in here. Rational functions. Rational function. Okay, new topic. Very, very complicated. Very, very complicated. First of all, definition. Okay, what is that? What is a rational function? Well, rational function is a new function. Okay, I want to call it for x. A new function. Okay, is the division to polynomial. P of x divided by Q of x. Now, who is P and who is Q? P and Q both are polynomial functions. Okay, where P of x and Q of x both are polynomial functions. Let's see the definition. Okay, however, one important thing to say, Q never is 0. Because you know very well what happens when you divide by 0. Totally out of the domain. So no 0. No 0. Q no 0. It's the only restriction. Okay, let me present to you different example of the rational function, and we analyze the different things. We analyze functions, factory form, okay, it's only factorization any polynomial P and Q together separately. And the thing can happen with your factorization. And domain. Example 1. Example 1. Example 1 is pretty easy. SF of x equal 1 over x. Now this is the function. Now the factory form is always the factorization of the top and the bottom separately. Well, in this case, it's impossible to do anything because this is elementary kindergarten example. No, 1 over x. So 1 is 1. X is x. But domain is all real number except 0 because we cannot divide by 0. You can write like that, or either way, or you write, for example, in the interval notation, gets from negative infinity, comma 0, no include 0, of course, and union 0, comma infinity. It's either way. Well, no, either way, depending on the test. The test sometimes enforces to you express in interval notation. So you need to be familiar with the interval notation. Interval notation is universal. Set notation is sometimes it's easy, but sometimes not. This was the first example. Do you understand very well the first example? Let's move on to the second.
Yes.
It's more interesting. The name of the function is g. And G is the one monomial in the top, degree 2. And one trinomial in the bottom, degree 2 also. Okay, no problem, I understand. Entonces now in the next column, the only thing we are doing is factorization. Well, on the top is a monomial. We cannot do anything. However, in the bottom is trinomial. Yes, we can factorization. It's super easy. The combination is 3 and 2. 3 and 2 because 3 times 2 is 6. And somehow 3 plus 2 is 5. And the sign is negative. Negative. This is the factor 4. And this is the original gets given. No, gets confusing. And the factor 4 is more clear. Now the domain is all real number such that x no 3 and no 2. It's a bad guy, right? So you express it in this notation is, well, from negative infinity, comma 2, is the first, union 2, comma 3, union 3, comma infinity. Then conclusion is the all real number line. Here, let me try here. Sometimes some students, including me, require do the sketch to understand, no? Because I am lost. Basically, we have two holes. One hole in 2 and another hole in 3. Because you know, so you plug in 3 here, what happened? 3 minus 3 is 0, division by 0 undefined. And like what happened in the 2 minus 2 is 0. So we have two holes, one hole in 2, one hole in 3. This interval, this interval, and this interval. This interval is this interval is this, and this interval is this. Clear?
Yes.
Okay, entonces, you need that, you are doing this case. You don't need no problema. Some students don't need that. Okay, entonces now, let me erase that part. Entonces, in this value, okay, to be undefined, the function, normally, not always, but frequently, 99%, we have one thing is called vertical asymptote, okay, I want to explain in a few minutes. Vertical asymptote. At x equal 3 at x equal 2. I want to explain. No, don't worry for this too much. It's only I anticipate the name. Maybe you don't understand the meaning of this. It's clear for me. Let's move on to example 3. In example 3, we have one weird situation. Okay, suppose the function is called h of x, is the name, and this is x plus 3 divided by x squared plus 4. Suppose que is given this expression. Degree of the polynomial in the top is 1, linear. Degree of the polynomial in the bottom is 2, is quadratic. But I can see it's impossible to do the factorization in the top because it's only one binomial. Here it's possible also because this is the irreducible quadratic equation. Okay, it's important to say something. Suppose we have x squared in another hypothetical example minus. Entonces, in this case, yes, it's a different, the famous difference of a square, and the factorization is 2 plus or minus in the story. However, when it's plus, it's prime expression in the real field, because I know in the complex field, yes, the complex field is x 2i plus or minus. But in this section, never we are working in the complex field. Always the real field. The assumption or supposition is real field. Never. When you see plus, whoosh, this is smell bad. It's primary pressure. Irreducible quadratic. Yeah, I know. Okay, when you try to investigate restriction, you put x squared plus 4 equal to 0, you get complex solution, no? And complex solution is totally out the real field. Therefore, we have no restriction. So when you in algebra try to find something that you suppose can exist, and you set out the equation, and you are doing your best. Best is 4. And suddenly magically happen. Wow, it's imaginary complex. It's because the thing you try to find doesn't exist. This is important that you get this idea. I suppose you remember when you study quadratic equation, that the parabola sometimes do not cross the x-axis. And this situation happens because it's complex, the zeros of the parabola. So we have no restriction. See, we have no restriction. The domain is all real number. All real number you can write in English, all real number, or more elegant, is from negative infinity to positive infinity. Something like that. Correct? Everyone follow me? It's clear or it's totally crazy, confusing?
It's clear.
It's clear. One more example. Example 4. Just this part is the introduction to rational function. Entonces, I promise que after that, I want to study, because there are several details. We study detail by detail. And after we integrate everything in 3 or 4 examples, in the lecture, no? In the review packet, we go over again. Okay, so the example for the introduction part is P of X equal, okay, let me try, make it soon, is, let me copy here, no, not here, because I need more space. P of X is equal x squared minus 11x plus 30 divided by x squared minus 9x plus 18. Okay, this is the given expression. The first step always in the analysis of the rational function is express it in factory form. You dedicate your time now to do the factorization, the top and the bottom separately. It's easy in this case, it's not complicated. Degree 2, binomial, x. And the combination in the top part is 6 and 5, because 6 times 5 is 30, and 6 plus 5 is 11, and negative both sides. And the second one is x is 9 and 6 and 3, 6 and 3, because 6 times 3 is 18, and somehow 6 plus 3 is 9, negative both, again. Entonces, I bring this example to explain one new idea. Wow, you see now that this factor and this factor is cancelled out. Wow, disappear, okay. And this P function is now x minus 5 divided by x minus 2. Okay, and we, from now, we start working for this, because it's easier than this. And wait, I need to explain something super important. They are equivalent 100%? No. So this P, let me call P1 to differentiate a little bit this and this. They are twin brothers, but not exactly the same. Twin brothers, but some different. So P of X is equal to P1 of X. But we have one restriction, and the restriction is for no 6. Because in 6, So the factor gets canceled is considered like a whole. So we have at x equals 6, we have a whole. Okay, whole is different to the vertical asymptote. Because when you write the domain, look, let me write the last part. The domain is all real numbers such that no 6, comma, or 1, either way, no 3. But the behavior of 6 and 3 is different. This is a whole. And this is no whole. This is the number que stay in the bottom here. Entonces it's illegal to be 3. This is the vertical asymptote. Similar to the thing we see before, vertical asymptote. But in both scenarios, it's completely out of the domain. The function, the original function, no P1, sino P, the original P. P1 is the simplification of P, but under the consideration, when you delete mentally, or mentally no, in the piece of paper, x minus 6, you consider that we have a whole. And the representation of the whole, when you are doing the graph, okay, promise we are doing several graphs from today, it's like that. Suppose that this is the curve. Entonces, suppose that in 6, we have a whole. The representation for the whole look like that. Boom, whole. And you put a circle. Similar to the piecewise function that and this is completely open. It's a whole representation. The vertical asymptote, no. The vertical asymptote is a vertical line that you represent always like a dotted line. Tan, 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 tan. And the curve approach it and never touch. Because the touch is undefined. I don't know if in this direction or in this direction. We study in detail this part after that. Do you follow me? Everyone follow me? Complicated, easy, horrible, weird, confusing. Any question about that? I try to, for example, illustrate any possibility. Any possibility is, can we have asymptote, vertical asymptote, is a bad guy, is a undefined value. We have no vertical asymptote. The example 3 is a classical example in which we have no vertical asymptote and no whole. Everything is continuous, nice. The graph look like maybe like that. Moving that. This is continuous. No. This now we have two vertical asymptote. One vertical asymptote in 2 and another vertical asymptote in 3. Entonces I don't know, I have no idea how it look like the graph. But the graph approach it, maybe, I don't know. We're using Desmos to see this. But the thing I try to explain today is to be familiar with the thing we expect to find. We expect holes. How do you know get hole? You factorization. The factor gets gone, cancel out, boom, it's a hole. And the representation for the hole is like that. The factor can stay alive in the bottom is the vertical asymptote. Vertical asymptote. Any question, guys? We have 5 minutes. No, 5 minutes, no, 10 minutes. Let me present to you definition of the vertical asymptote. See, you have no question. No question. Everything is clear?
Clear.
Excellent. Okay. I want to study now in detail the theoretical part of the vertical asymptote. I promise. Okay, in your moment, you see examples. No? Maybe today, maybe next time. Okay, definition vertical asymptote. Okay. Okay. Definition. You know, Mathematica is the format to explain the Mathematica is definition, one definition, for example, two theorem or rule, and 1,000 example to understand this. Okay, one definition, one theorem or two theorem, no more, and 1,000, 2,000, 3,000 is up to you. Example. So what's the idea behind vertical axis? Well, when you approach it, you using this symbolic way. Look, X approach it. Professor, what means this? This is not equal. No. It's you moving. Look, this is my all real number line. Look, this is my all real number line. I'm supposed to C. Maybe C is confusing for you. C is one number. Approach it to 2. What mean that? Well, suppose this is a line. This is x-axis. I don't care what axis for the moment. And this is 2. And approach means you walking close to this. But we have 2 directions in 1D, no? In 1 dimension. We are talking about 1 dimension. You approach it to the left or to the right. Left or right. The convention in mathematics, approach it to the left or to the right, is a little bit confusing. It's x approach it to the 2 minus and minus left, and x approach it to the 2 plus, and plus is right. And don't confusing que es x approach it to the negative 2 negative. Wow, this is the regular negative 2 that you see in your entire life. Negative 2. Negative 2 is here. Suppose que negative 2 is here, and the approach in that case is to the left. So it's basically in that direction. You understand the notation. The notation is a little bit confusing and complicated to understand. So this sign over the number indicate the direction in which you approach. Okay. So when you approach it to the one number, maybe 2, maybe 4, maybe 20, and the function, que sea for x or y value, approach it to infinity. Let me erase that part. So when the x approach it to one number, maybe to the left or to the right or both. C plus, right. C minus, left. I put C to generalize the idea, no, 2, 3, 4, it's a number. And the function or y gets the same, you know, function notation. Approach it to infinity positive or infinity negative. We are talking about vertical axis. And this is the reason. Remember, infinity is a symbol. Infinity is no number. Infinity we cannot manipulate arithmetically. Infinity plus infinity. What is infinity plus infinity? What is infinity minus infinity? This is crazy. You see a little bit in calculus, but it's very, very complicated. It's symbolic. We cannot manipulate like a number, the ordinary number. Be careful. So now, to see, visualize this idea, I propose you do 4 possibilities. 1, 2, 3, and 4 possibilities. Make it so. 4 possibilities. Suppose que the famous C is arbitrary point. Suppose 2. I don't know, I like 2. 2 here. 2 here. 2 here. 2 here. I suppose that we have into 1 vertical asymptote. And the vertical asymptote, guys, the convention when we are doing in decimals, by the way, when we are doing in decimal, in decimals. Always the convention is black color dotted line. Black color dotted line. After, when you are doing the example, you see in decimal how. You see that. Okay, baric acetone, baric acetone, baric acid. 4 examples of the baric acid. 4 possibilities we have. And suppose that the curve look like that. Ooh. Approach it, but never cross it or touch it. Illegal. Totally. Because it's undefined. Suppose que this. This arrow indicates that it's continuing forever in that direction. Suppose this. And suppose this. Okay, so how you determine the location of the baric acid? Okay, easy. You take the rational function f of x is equal to p of x divided by q of x. Immediately you are doing the factory form. Suppose que one factor is cancelled out, but I take another letter for suppose t of x over, I don't know, m of x, and the factor can stay alive at the bottom, you put equal to 0. And the solution of this equation give me the location, the position of the acid. Suppose hypothetically I get 2, 2, 2, 2. To investigate the behavior, because we have different kind of behavior. Behavior 1, behavior 2, behavior 3, behavior 4. It's easy. You investigate left and right. This idea, left and right. Does this look like complicated symbolic? No, it's easy. You pick one arbitrary point to the right of 2, 3 maybe, or 4 or 5, 6, 7, and 1. And you evaluate the function. The function in 3 is negative. The function in 3 in this hypothetical example is positive. This is the behavior is like that. Boom! You analyze the sign. See, both are positive. Boom! See, this guy is positive and this guy is negative. Boom! And see, both are negative. Option 4. Super easy. Yes or no? So I suppose okay, we have time to do. No, we have no time. I propose you finish here, guys. Listen to me. For the student that I've known at the beginning, let me stop recording.